Yes. Welcome also in this afternoon. Are you trying to? Oh, perfect, perfect. Now we are still using this file. You have also received my version. Hopefully, it is similar to you. You can see each other probably in the same thing. And we have included the object of the line and the object of the bus. And also we have calculated this admittance matrix just for a line and two nodes. That is the A equal to the equivalent elementary admittance matrix of a branch. And I will try to put the equations. And the equation that, can you see, read here? I cannot because, can you see, read? So you can also approach a little bit if you wish to stay here, you can also see there. And I will try to also enlarge the script. I will try. Because for me, so I have tried to enlarge, but so we are here, and these are the equations that we need to include. So I will go directly to put the equations that are the equations that we need to solve with the fsolve. So the idea is that we write the equation and the solution is provided by fsolve. That is this library that is called at the beginning. We import from the library SciPy optimize, we import fsolve. But we need to use fsolve, and fsolve we have already written the instruction, solution, hopefully, fsolves, but the first thing we need to give to fsolve the equations, and then the initial guess of the solution, and the arguments that are needed for. So I will write this equation, how to put the equation inside in a function. Do you remember how to write a function in Python? It is def, and then the name of this function. Since we have written equations, I will put equations here, but you can also use another name. So, I will write the equations. Equations, the name of a function, or you can also change the name. And then inside the equation, we need to write our equations. And well, what are the equations? Are these two. So these two are the power flow equations. So the power injected, active power and reactive power in bus K, it is equal to the voltage in bus K times the summation for all the buses, the voltage of the bus, Vm, that can be also K. So in our case, it is a single line. So bus 1 and bus 2 will be both bus 1 and both bus 2, and multiplied by the G, that is the real part of the admittance matrix, multiplied the cosine of the difference of the angles, plus B, that is the imaginary part of the admittance matrix, multiplied the sign. So we need to write this. So for this, we need that our equation has some variables. So we need mandatory to have that this is a thing that we need to say to our equation, that are those things that needs to be calculated. So these are vars, but the others are the parameters, and probably one of the parameters will be the admittance matrix, and also we need the voltage that is set. We said that in bus 2 the voltage needs to be the rated value, so we have stored this here. So also we want that in bus 2 there is a certain active power and also reactive power. So we need also the set point for the active and reactive power. We can say S set, that is calculated, stored here, the values we have put in the object bus here. Here you see that we have collected the power. We said that in bus receiving there is this P load, so we are, it is minus because it is not injected but is absorbed by the load. And we have stored this information in this vector S set. So S set is here. And then we have also the information which is the sending and receiving bus that we have stored in this index, in this list, who is the sending node and who is the receiving node. For us, 1 is the sending node and 2 is the receiving node, because our problem is just very simple. One single line with a load here. And we fix the voltage here equal to 1 in per unit, so the rated value of the voltage, and we want to calculate the voltage here. So this is the sending bus and this is the receiving bus. It is bus 1 and bus 2. Please stop me at any time when you have some doubts. So I put also here this information that is the index, who is the sending bus, who is the receiving bus. This is stored in this. After the first line, at the end, we need to put a column. So it doesn't mean what are the instructions of this function. So we start, and if you put enter, you see that we are not in the first column. We are a little bit indented because Python has no the end, no instruction or parentheses. Is just use the indent in order to identify what are the instructions that are included in our function and what are the instructions that are outside. So inside here, I wanted to say, yes?
The last one is IR.
Yes, IR. Thank you so much. IR. So we wanted to use both. Then the first thing that I probably need here is to know the number of buses. So I will write again n bus. Because I have not passed as an information, we can, and I would like to link this n bus with a number of variables. How many variables we have? Oh, we have the voltage in modulus and in angle in all the buses. So we have 4 variables. Magnitude, voltage in bus 1, in bus 2, and angle in bus 1 and bus 2. So 4. So how many buses? It is the number of variables divided by 2. So I will put len. Len, it is the length, how many components are in bars. And I would like to put in 2. But then it comes Python, that he wants to be sure that n bus, it is an integer number, because we will use as an index. So he wants to be sure. And in this he says, but if the number bars, the number, it is 5 divided by 2, it is not integer. It doesn't know that is. So in order to be sure and not give complaint from Python, we have put this symbol that is divided. It means that it is the division taking just the integer part and not the. So if you divide 5 divided by 2 with this thing, you see that it is 2. 5 divided by 2 is 2 because there is this trick here. Then the number of equations I need to store. So I can create just a list that I will call equations. That is an array that includes the values of the equations or the residuals because they are equality constraints. No? So we write this equation because we want that this equation gives P load in the receiving bus. And we write this equation in order to have a 0 reactive power in receiving bus. So our equation are indeed the difference between this equation and the set value. So and F solve find the 0 of this difference. So the vars data takes this constraint as equality. We need to store this value because it is used by the solver. And at the first we need to initialize. So I will initialize this values, these arrays as np at the beginning zeros, and then we will put our, and how many, and since there are 4 variables, we need to write 4 equations. So they will be 2 times n bus. So these are the equation, and I would like also to write the equation not using vars, but I wanted to use angle and voltage. And so I decide that the first, vars, it is a thing, an array of 4 elements. So 4 elements. I decide that the first 2 will be the angle of the voltage in bus 1 and voltage by 2. So the first are the angles and then the modulus. So I put in an order in this way. So this is vars. And so I can define the angles and also the RMS value of the voltage, the magnitude of the voltage, the modulus of the voltage. So I will the modulus I will put abs V, and this is the angle. So I'm here. So I can define angle, just in order to simplify the notation when we write the equation, angle equal to the vars, but only the first n bus. So in order to take the first, we don't write nothing, just the column and then n bus. So we extract from the vector of the variables just the first n bus elements, and then abs V equal to vars, and then the last elements. We know that saying that is 2, the number of buses, the first it is 0 and 1. So element 0 and element 1. Element 0 and element 1, that are the angles. And then in the second instruction we put 2. So we put 2 until the end. The end is 3. Because Python starts counting from 0. So it is n bus until the end. I need to put n bus. Now we are ready for the constraints. And all the constraints are in the receiving bus, because we see that we need to say that in the receiving bus the active power it is PL, the reactive power is 0, the modulus of the voltage is 1 pm, and the angle, because we can fix also the angle, it is 0. So we write all the equation looking just at the bus, at the receiving bus, because we know everything for the receiving bus we need to calculate in the sending bus. So we can say the node here, it is written in K, so I will say K, it is equal, and it is the index of the receiving bus. So IR I define as a list. Indeed, it is just a single number, but Python gets confused. So I need to say, since it is a list, which is the element of the list? Of course, it is the first, because there is only one. So I put 0. And then we can start with the first equation. So EQS. I'm starting with the first equation. So for Python is the element 0. And then I will write the active power, so this equation here. So it is the voltage abs of voltage in bus K that we have here. And then it is multiplied by the summation by the summation. And you see that here we have the summation division of Vm. So we can write abs V, an index M, multiplied by it is the cosine. And we also need to multiply it by the G, so the real part. So for the real part, I can mention Y, that is our admittance matrix, and the elements are K, and M. But it is the real part is G, so dot real, and then times, and then the cosine. So the cosine, it is in the NumPy library, so NP dot cosine. And it is the angle, so angle V in K minus angle V in M. So this, can you follow? Is it fine? This difference of the two angles are the difference of the angles at the two terminals of the lines. So we are here, and then you see that we need to multiply also for this part. So since it is very similar, I will just copy and paste this, copy and paste here. So you see plus, and then this equation ykm, the imaginary part, so imag, and then the cosine, it is not the cosine, it is sine. So you see that the equation is the sine. The only thing is that this voltage needs to multiply both. So we need to put these two parentheses. So abs Vm multiplied by this, and then we can close at the end. It is a little bit difficult for me to keep everything. I can go in another row. Sometimes complain, sometimes no. We can try. So I will just go in another row here and keep enter. We can also put some space so it is more. In order to avoid problems, sometimes it is useful to use this symbol, that is the slash, no? And that says to Python, it is the end of the row, but the instruction continues also in the other row. Sometimes complain, sometimes no. We will see. I have missed one thing here. What to say, I mean, to close the summation, you see that I have not closed this parenthesis, and to say to Python or to the summation with M. I need to say M. M are all the nodes, so this is the summation for all the M into the network, so all the buses, for us bus 1 and bus 2. So at the end of this, we need to say who are M. So we write for M in, and then we say in the number of buses for all the buses of the network. So in order to say that, we use this range. We have already used in the first lecture this range that says all the buses, 0 and 1. Buses are 1, 2, but Python starts from 0, so for him the index are 0 and 1. Is it fine? So range of n bus. So this is the summation. Is the summation of this part that is repeated for m equal to 0 and m equal to 1, bus 1 and bus 2. At this point, we can close the parentheses for the sum. So we have at least. And we have not finished. We have written entirely this equation, but our equation, it is not the equation. It is the so-called the residual, the error with respect to the value that we wish for the active power in bus 2, in bus receiving. That needs to be the power of the load. So we have stored this in sys S set, so we can say minus S set bus it is the bus K that is the receiving, it is the active power. This is the complex power, so we need to take the real part. So in order to take the real for the complex number, dot real. But we have already used for the Y and for this. Is it good? Apparently it does not complain. Hopefully. I want also to save because sometimes internet is not working, but now it's working. So I will not run because we are in the middle, but at least saving if there are evident errors. I don't know, there is no balance on the parentheses open and closed. He puts a sign here to say that. I will copy this equation as a equation 2, I mean the second equation, equation 1. So I will copy, Control C, and then Control V. Why I'm doing this? Because the second equation, Control V. I would like to copy, Control C, Control V. Yes, now it's copied. And equation 1. Why I'm doing this? Because the reactive power equation is very similar to the active power. There is a change of sign here, you see, and the cosine is sine and the sine is cosine, no other differences. So I need just to replace this real with imag. No, I've done something bad. I said that just change the cosine with sine and change the sine here. So cosine is sine, the sine is cosine, and this plus it is minus. Obviously this is a reactive power, so needs to be compared with the imaginary part of the power in the receiving end. And then the other two equations are not written here because they are so stupid. We need just to say that the voltage, the magnitude of the voltage in the receiving bus, it is 1 in per unit, it is the rated value, and the angle is 0. So we put also these two equations here, or residuals. Equation 2. AQS, and then I put 2 equal, and then it is the comparison, and we say just abs of V in K minus V set that we have already put here, V set in the same bus. So V abs, absolute value, of V set in index or bus K. And then equation 3, that is the last one, it is the angle. The angle should be 0, so angle. We have defined the angle here, angle, the variable in node K minus, and we can say that it is 0 or it is NP angle. This is a function that is NumPy that extracts the angle from a complex number. NP angle and in parentheses V set. Always in bus K. Is it reasonable? We can also print these. Probably we will need, because it will give an error, so we can detect where there is the error. Otherwise, I mean, if you don't need any printing for just checking or something like this, we can close the function. How to close goes right in the first column. But before closing, we need to say that this function needs to be used by the fsolve. So we need to give to f solve the result. So we need a return instruction. So at the end, we put also a return. And what is the important thing? It is the value of this residual, so EQS. So this function will be used by fsolve iteratively, with is in mind, in order to minimize the equation. So I think that will be good in any case to put also a print of these equations here, or the values, in order to see at each iteration of fsolve what he is doing or not. Is good? Now we can use our fsolve. You see that we have put in a comment at the beginning in order to understand what we have done these equations. We need also to give to this fsolve a first tentative solution, and we can use the usual way to put just as an initial tentative solution the first values that we have, so 1 and 0, 1 modulus and 0 for the angle for both bus 1 and bus 2. So we need to define this, I call it initial guess, but can be the name that you wish. It is just in the second position. At the beginning I put zeros for everything. So we have two. It is the initial guess for our variables. Our values are 2 times n bus, and the initial guess for the first n bus elements is 0 because are the angles. We can also say that it is equal to np angle of V set, but we have put 0 for all the imaginary part of V set. And initial guess, the elements, the last n bus elements, so we start with n bus column, it is equal to the absolute value of V set. Any doubts until now? So we have almost everything. We can also take away of this symbol, so it is not a comment. This hashtag, I don't know. And so it is not a comment, but we need just to put here the arguments. And the arguments are the arguments of the function, so we can go above and say, oh, there are these arguments, so we can take these arguments and put as the arguments of fsolve. You see that I have not put also vars, because it is not an argument, it is the variable that is updated by the function, so fsolve. So fsolve solution will be the results, arguments here, I put the arguments here, Control V. Is complaint somewhere here, undefined angle is not undefined. I thought that there was inside a numpy, so I started with numpy as an np, and np as an angle. So y is complaining. I'm saving. Still complaining, name undefined angle. Why? I will try to run. At this point, undefined initial guess. Undefined initial guess, but it is here. Initial I've written in the same way, so it is defined. So I will try. See? Running here. So The error that it says is that initial guess is not defined. Initial guess is here, it is written in the same way. It is undefined. Any suggestion? Ah, yes, big error. We are indent. So he thought that we were always writing inside this function. We are still inside the function. The return does not close the function. The function is closed when we keep in the first column. So we are in this way. So now we understand that here we end the function because we are not indent, but we are not. But we are back in the first column. So in this way, it is like to have an end of the function that is not present in punch. So we are in the first column and we try again. So now it's complaining with the angle in equation 3. And it says that, this angle, I was looking at this, but it is this, because it is not angle, that's all. It is angle V. It is the name of this variable. It is just the angle that we have put, so it is angle V. It was not, I was focused on this, but it was just this mistake.
V is capital.
And capital, and is there was the cap lock that was he has done something. At least he is not complaining. So we need to understand what are the thing. But one thing that I like, that I put the print. You remember that I put a print inside fsolve, and at first these values are quite high. Oh, obviously these are 0 because we have said that the initial guess is also the final solution, 1 and 0. But the first two times it is high. It does not in several iterations, but then starts to iterate, and these numbers decrease. This is 1008, but this is minus 2. E minus 2 means 10 minus 1, so it is 0, 1. And then there is minus 1, minus 2, minus 3, minus 5, and there is the last row that is minus 13, minus 12, no? So these numbers, minus 25. So these numbers are saying to us that probably we have written something bad in our function, but he has found a solution of the problem that we have given. So it reaches the convergence. So we need to extract now the results. And you see that the results are in solution. So if I put a solution here, it gives us these are before angles and then the voltage. So these two are the angles. So you see that he has calculated the angle in the bus 1, that is 0.4. And also you see that there is the voltage in bus 1. This is the voltage in bus 1. The voltage in bus 2, it is always 1, no? So in agreement, also this is 0. For me, E minus 25, 10 raised to minus 25, it is 0. It's good? So we need just to collect these results from the solution. So I will just put here some storing of the results, so we can put a comment here. And we can say that angle V, now it is the solution, the first n bus elements, so column and bus. And the hubs of the voltage are the second part of this array, so n solution, n bus. And then the column, and we close. So we have stored our thing here. In many cases, we don't want to have the angles in radiant. It provides radians because the cosine are in radians, so all the variables are in radiant. But many times we put in degrees. Do you agree? So we can convert this angle in degrees, so we can multiply it by 180. degrees and divide by pi. Pi is not available directly in Python, but in NumPy, yes. So we put np pi. We can also print. We can also put a nice print. It is not so important. Print, I do apologize, for I in range and bus, column, print, and the formatted print will be F, and then we need to say, I don't know, we can say voltage in bus, and then it is the bus, we can say here I plus 1, because we are starting numbering the bus from 1 and 2, and Python it is 0 and 1. And then it is equal to the hubs. Impar embraces what we need to take from the program. V hubs, V, the absolute value of the V. It is always I. We can also choose not to print all the decimals, so we can just limit our printing just for the 3 digits after the dot. So we can say, for example, z dot 3f. So we can limit in the floating number just the 3 digits, or 4, as you wish. And then we can also put 4. And then the angle. Angle V, it is the element I, and also for the angle we can just put the 4 digits after the dot. At this point we can say that this is the value in per unit. Perhaps, these are degrees, so we can also put the symbol, if I found, because it is probably there is no the symbol in the keyboard, but we can put deg. So this is totally in per unit, and then put this, and then close the parentheses. We can also we can run, because we wish to know if the results. So you see the voltage in bus 2, the receiving end is 1 and 0 degrees as mentioned, and the voltage, so we have calculated the voltage in the sending bus. So it is 1.1105 and 27.7677 degrees. Okay. Do you have any comment until now? Is it running also for you? We can also calculate the power at the beginning. Is it? Or we can also print the power at the beginning of our branch. So we can also say for I. I will put the list of branches, because we are now taking the power in the list, and the list of branches least branch. And then I need here to calculate the flow in each branch. Oh, we can calculate here, but we can calculate directly into the object. Do you have any comments until now? It is a little bit. It's good. We can calculate here, but we can calculate inside the object. So we can go directly inside the object of the branch, here, in which we have just the initialization, so the definition, and put here another function, another method for the object of the branch. That is the method that calculates the power flow into the line. So in order to do this, do you agree? Okay. Oh, but we can define another function that is not mandatory. In it is mandatory in order to define the object in Python, but here we can add other methods. And in particular, in this case, for the object line, we can put a method that calculates the power flow. So when we know the voltages, and now we know. So we can take here def. We are inside the class, so we need just one indent, because if we put in two, we are inside this function. We need to be inside the object, not class bus, but class branch. So I do apologize, I'm going to the class branch. Inside the object branch, we put another method, def, and this method is the calculation of the power flow when you know the voltages. So def, we can write power flow, I put here, but you can use any name. For sure this needs to know the object, so self is storing the object, and then needs to know the voltage in K and the voltage in M. So the two voltages. We can say that, I need to put a column here to write the equation, so we are in the second indent, you see, and then I can write just that Vm, because they are complex numbers, so we can say that Vk abs, it is equal to the absolute value of Vk, Vm abs, I don't know why I've chosen to write in this way and not abs Vm, but abs Vm, you can choose other names for the variables, and then I can also define theta, because it is the difference between the two angles. So theta, we can say theta km, that is the difference between the angle and P angle of Vk, minus NP angle of Vm, and then we can write the equations, and the equation needs to be revealed also outside the object, so it is better to store them in self, the self dot, and we can say the complex power xkm, that is going from K to M, and how we can write this? Oh, we can write the equation with the sine, the cosine, but there is another equation that gives you the power. That is that probably I've written here. Yes, it is the power, it is equal to the voltage times the conjugate of the current. And we know that the current is given by the elementary admittance matrix multiplied by the voltages. So we can take this elementary admittance matrix multiplied row to column to the voltages, and we get the currents. The currents conjugate multiplied the voltage gives the complex power. Is good? It works? No? The power is equal to the voltage times the conjugate of the current. We know for the branch the elementary admittance matrix. We know the two voltages, V and K. We multiply the admittance matrix with the voltage. We obtain the currents. And the currents conjugate multiply the voltage. We give the power that is injected in bus K and injected in bus M. That's good? So we can try. We try. And we will see. We have also the check, because in bus 2 we know that the power needs to be the power of the load. So we can write SKM equal to Vk times, and then in parentheses we need to store the current, and I put the parentheses because I wanted not to forget to put the conjugate at the end. So I put just at the beginning. So dot conjugate. Unfortunately, this is a function for Python without arguments, and it wants to open and close the parentheses without arguments. So this is a strange thing, but we need to write this. Here we need to write the current, so the elements of the admittance that are here in self Y here multiplied by the voltages. So we take the first two elements of self E yes, okay, so self dot YE, the elementary admittance matrix self dot YE, the first element, it is the first row, the first column, so 0, 0, and this is multiplied by Vk, and then plus, and then self YE, first row, second column, multiplied, second column, so 1, multiplied by Vm. And the same equation can be also written for the power, or this needs to be indent with the other, no? The alignment is very important for Python. So self mk, it is the second row, so it is Vm, that is multiplied by self second row, first column, Vk, second row, second column, Vm conjugate. If we have written this, I'm saving in order to see if there are errors, evident errors here. Hopefully it's saving. No, saving, there is no. Save to save. The internet is not working, but I will complete the instruction after, so we can just check internet connection and save and see. So I will just put this information here in the back. So power flow, I define this function. Hopefully this function provides this self SKM, self SMK that are the power at the two terminals of the line. So at the back, in the for in list of branches, I will say I dot, and then this name of this function that we have put, and we can so calculate I power flow in parentheses, and then here we need to say what are the voltages. So for us the voltages are I can put here, since in order to be more sure, we can say that we can define an array for the voltage in which we can store all the things. So we can, I do apologize, other than printing, we can store all the voltage or all the solution in an array, so we can define here a voltage array equal to NP zeros with the number that is n bus. In order to be sure that they are complex, I put also d type equal complex, because 0 can be also integer. And inside this for, other than printing, we can also add the instruction that we want that the results is stored in V as a complex number. So we can say abs, can say VI, and then it is the abs VI, and then multiplies by a phasor. It is the modulus multiply the exponential function with the exponent j and the angle. So the exponential function is npexp, and the exponent, it is 1j multiplies by the angle. So it is angle V. I made an error here, that is, unfortunately here I converted the angle in degrees. So in the phasor we need the radiant, so we need to be back for this. So we can multiply just for np dot pi divided 180. We do the reverse. And then close the parenthesis. So in this way, we can put here in power flow directly this value of the voltages. And so we can say that it is the voltage in I dot k, but Python start counting from 0, so -1. And then the other voltage, Vm, it is the voltage I dot m, because I is our branch that has a node K and node M, and always -1 because we are numbering the bus 1, 2, but Python numbers the bus as 0, 1. I'm trying to save again. Oh, now I saved. So we can also run. There is an error that says that this angle V needs to be the angle of bus I. So it does not give any error. We have not the printing of the flow, but we can print here. So we can print in F, for example, and we can say the active power P. We can say the initial bus, it is I dot K, and we can put, I don't know, a symbol like this to say the direction. I dot M, so this is the power from K to M, it is equal. And this is stored in I dot skm, but it is the real part, so it is dot real. And this should be in braces, and we can also limit here the number of digits to, we say before 4 f, because it is a floating point. And then these are in per unit, close the parenthesis, and then we can also write the same thing, so I'm copy and paste for the reactive power, and the reactive power is the imaginary part. The imaginary part, and we can keep all these and copy and paste again, replace K with M and M with K, So we have the flow from M to K, and is always mk and mk here. Dot. Save. Run. Is it reasonable? Apparently yes, because the power in the receiving bus was 1, because we have chosen the P base equal exactly to the load. The load was 125 megawatt, we have chosen, so the load in bus 2 is so the power injected in bus 2 is -1, because it is minus the reactive power is 0 here, but you see that at the beginning of the line the reactive power is not 0, because there is the reactance and the susceptance of the line. I would like to share with you this, so I can try to share. Control C, close, and then perhaps I know how to do here. I kindly ask you an help, or oh no, it is one of these GIAN course. Thank you. Sorry for the intrusion of your WhatsApp. I do apologize. Is it working? Is it? I can make a tour. Is a little bit working?
Yes, sir.
Good, and so you can compare. Did you follow something? Yeah. We can also try. I don't know if you have other 10 minutes. Do you have 10 minutes?
Yes.
Yeah, we can use the same file in order to put other two lines. And so we have 3 lines instead of 1 line only. So, and this may justify the fact that we have built an admittance matrix and so the things, because we know that that problem can be solved directly by our. Also in the presentation, you see that the same results can be obtained just directly saying, I need to check. Yes, apparently there are the same results that can be obtained directly by the knowledge of the power and the voltage in bus 2, and then you get the current, and then if you copy and paste this in Python, you obtain the same result. So, but we have done this because we can also think to do this kind of problem that indeed there are 3 lines, no? So we can implement this. Here, I don't want to modify this file, because this file is so nice, no? It apparently is working, so I'm so happy. So I will just save. Here below we can also exit. I don't know if I'm able here, because exit, open and close a parenthesis, and close the console, and then in the top I can go to the directory, my directory. You see test2. In Python anywhere there is no double, no, make a copy, no. So, but we can do one other thing. So you can open bash console here with this instruction. It opens a console just for the environment. It is Linux. So you see that we are not in my computer. We are in They say in the cloud, I don't know. It is fresh there. And ls, you see our file here. And so we can copy the test1 pi with another name. And so, for example, cp test1.py in test2.py. And then, if you see ls, we have the list. We can exit also here. So the console is closed, so we can go back. We are here also test2. Test2 is equal to test1, but now we can modify a little because we want to solve 3 lines instead of 1 line. I will start and then okay, what do we need to modify here? For probably it says here that there are no indication for the power. The power is about 100 megawatt and so on. There is no indication, so I will prefer to use the simple P base equal to 100. So I will not put something very specific, 125, and so this is 100. All the values are already given in per unit for the lines, so probably I don't need even to know what is the V base. We can assume that is 215 kilo, but it is not needed for the solution of the problem. And then we have this thing, ISIR. It is receiving and ending, but we are not classifying in receiving and in sending bus in the power flow. What is the classification of the buses in the power flow? 2 letters, PQ and PV. So there are buses in which we fix both active and reactive power, buses in which we fix the power and the voltage. In this problem, there are no PV buses because in general are associated with a generator. And here in this simple example, there is just one generator. So probably this keeps another role. What is the other role? It is for the students, for the slack bus, no? Because we don't know the losses at the beginning, so it needs to compensate the losses. So there is also a third bus that is the slack. So we need this. So here we don't differentiate between sending and receiving. In this network, it is difficult to say this is a receiving or sending. It can be both, no? But we classify according to what we know. And here we know active and reactive power. So these two are PQ buses. And this is for sure a slack bus because we need a slack bus. So in our list, we can put here, instead of these two things, IS and IR, I can put also a comment here, but I can also delete. So the hashtag is always hidden here. The hashtag is needed to do the comment. We can put the different list, and in particular IPV, that is empty at the beginning and probably in this example will be empty also after, and IPQ, that is empty at the beginning. Oh, I would like to put also a slack because we need to know where is the slack bus. So probably these instructions, the only one that is needed is P base because all the other elements are already in per unit. And then I need to say in the buses, so all these are fine. Yes, it's true. We have defined this absolute and we have not, it is not needed. So probably we have written some instructions that are not needed because probably I was thinking about something else. Can also avoid to write this instruction here. because our equations are written directly by using Vk and Vm and not the absolute value. So, okay. And then in the buses, instead of defining the buses R and S, we can say if the bus type is PQ, do put in a list. If it is PV, it is in another list. So we can say PV here, and then here append in the EPV, append EPV, IPV, it is the list here, that is here empty at the beginning, but we append the nodes. If the type is PQ, we need to append in the list IPQ. And we can say else, or if bus type is equal to, we can say slack, then put in slack. Dot append. And it is node k minus 1. Minus 1 is due to the fact that it's starting to count to 0. And then we can include now instantiation. This was the previous example with a single line and so on. So we don't have these values, so we can also delete. I will delete this. And we need just to put in all the branches, which is the branch. So here from 1 and 2, and this is the impedance. So branch between 1 and 2, and then the impedance is 0.02, 02 plus, and then 0.04. I'm missing something. I'm missing J, because 0.04, it is the reactive power, the imaginary part of the impedance. And then we need to put the admittance, and you see that in this example there are no shunt admittance into the line. It is neglected. So we need to put 0. So we can put 0. The one is just the ratio, but this is our lines, so there is no transformer, so I put 1. I do the same for all the lines, so not only 1, but also the other 2 lines. There is a line between 1 and 2, the line between 1 and 3. That is 1, 3 is the bus, and the impedance is 0.01 plus 0.03. And the last one is between 2 and 3. That is 2 and 3. And the impedance is 0.0125 and 0.025. Now the bus. So we have here it is not receiving or sending, so I will put just N1 and 2, and then N3. The bus 1, the first element, it is the power. I do apologize, the voltage. So it is the voltage, so I can put in 1, it is the slack bus, and the slack bus has the voltage that is fixed and also the angle, so it is 1.05. 1.05, the angle is 0. And then the power, we don't know. We need to calculate at the end, so we can put just 0. And then it is calculated, and it is for sure a slack bus, because it is the only generator, so we don't have no choice. So N2 is this bus here. You see that is bus 2. The voltage we don't know, so we can just put 1.0 as an initial guess. And then what is the power? It is 256.6 for the active power, and the reactive power is 110.2. Is good? The minus is due to the fact that it is not injected but absorbed. So this minus says that it is a load. It is not perfect because I have here, I'm not sure if it is good, because I don't, we need to give to do the work in per unit, and it is fine because in per unit it is converted inside. So you see that we are inside the object bus, we are divided by p base. Is it fine? So we can do also for the last term and 3. It is the third bus. So bus in 3, again, we don't know the voltage, so we can just put the initial guess, 1, 0, the flat solution, and then it is minus 138.6 and 45.2. So this, these two buses are not receiving, it does not have any meaning here, it is a PQ, they are PQ. And then, well, I don't need to change anything. I mean, the thing is, I don't know, probably. We need to check. Probably we need to do something. So we have Vera. Cross the finger. Yeah. There is a problem. Bus type is not defined. Oh, I need to go up and I've written something like that. Yes, because I put another T here. Bus type, slack. IS is not defined. So. No. We need to modify something also after, because we have used our IS and IR also in the equations, but until the equation is fine, I don't know if it is good for you to just to see where we need to modify, and then tomorrow we can modify there. So the point to modify is here. Not much, but in the equation we put just these equations are just in the receiving bus. But here we need to write the equation for PQ and PV. So we need to modify these 2 points. So rho 84, so we need to modify this. And we can do tomorrow. Any questions so far? Good. Thank you so much. At least one line we have put 3 lines, so we need to make the calculation. But the equations are there. Thank you so much. Have a nice evening, and thank you for staying with me.
Thank you, sir, for the wonderful session.
So this is the end of this today's marathon session by Professor Alberto. So the tea is waiting outside session. Oh, perfect. Yeah, this is for all the participants also. You can join for tea, and then we will again